necessarily like projectors, but that is fine. Let me move this here. Boop, boop, boop. Okay, so the first part of this talk I actually gave at an anime convention. So some of the slides have anime characters and it might look a little weird. That's fine. I figured if you're at a Linux conference and you're learning about programming, you're probably okay with anime. So we're just going to roll with it. So let's go to... I should probably introduce myself. My name is Stephen Reaves. I work with Red Hat as a software developer. I work primarily with Golang and do cloud stuff. We work with Kubernetes a lot with our OpenShift program. Oh, this does not work. Let me go to Firefox. I'm really not set up. This is really unprofessional. Sorry about that. Okay. So the talk is going to be primarily about programming, like I mentioned. Here we go. Launch F2. Can we see this? Yes, we can see this. And then, can I do bada bing, bada boom? Sweet. Now I can see. I need to do this, right? There's a way to get the notes to come up. Okay, I'll just look like this so I can see. Okay, so as I mentioned, this talk was initially for an anime convention at Ichiban, which is really cool. It's also in Charlotte. It's in January. As I mentioned, I've been going to Self for a little bit. I've been going to anime conventions. I just like all kinds of conventions. You could probably have a boring convention, I'd go, just because it's a convention. So I really enjoy this sort of atmosphere. If you see me in the hallways, stop, talk to me, whatever. I try to be a fun guy. I don't know if I actually am. I've been programming for about 5 years now, a little over 5 years. I've been at Red Hat for 2 years, and before that I was working in a Microsoft shop. We were a supply chain consulting firm, and I was doing programming there. Another show of hands, who's ever used the X++ language? A lot less. No, it's actually built on C#, but it embeds like SQL queries into it has like SQL keywords in the language, and it has like these immutable container things. It's bonkers. It's really fun, but it's only used in like one program. It was made in like Denmark or something, and it's just sort of, I don't know, very esoteric.
Well, what program?
It's for Microsoft Dynamics. Okay. Used to be Exapta, and then it was AX 2012, and now it's Dynamics 365, because everything's 365. So it's a ERP, CRM, sort of everything suite. It's pretty cool to manage like sales orders and stuff. So very quickly, what is this talk not going to be about? What is this talk not going to do? We're not going to have people just walk out of here who have never programmed before and just automatically be software engineers. That's not. We need more than an hour to do that. This talk is more about introducing you to the concepts and going through some quick examples to see if this is what you want to do, right? Like some stuff, programming, computers, a lot of the stuff can be a little hard to get into. The old school of thinking is like, oh, you have to get a college degree, or you have to go to this boot camp, which is really hard. There's a lot of learning online that you can do. So I just want to sort of introduce this to people and see, hey, if you like this, go learn. And at the end, we have some links for some places where you can go learn online. But yeah, so this is going to be a very basic introduction, like I mentioned. So most people, as we mentioned, are programmers or have programmed before. But if you have not, a program is really just a recipe for a computer. You sort of assign certain things, your requirements that you need, and then you walk through a series of steps. Like if you're making cornbread, you start with your cornmeal and your flour, and you have to assemble the ingredients, and then you walk through, okay, mix it in this certain way, blah, 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 blah. And every time you make it, you get the end result, the output, which is cornbread. Sometimes you have to nest those programs, like if you're making cornbread and chili. The step 1 of that recipe might be make chili. Step 2 might be make cornbread. Well, then you branch off. But ultimately, it's just a series of steps and a series of ingredients. So going through this, we can think of it like a recipe. There are different types of coding. So I primarily manage like systems programming. So that's going to be just like regular applications you install. So when you install like Firefox, that is a application that runs directly on your system. But then there's also going to be web stuff. UI work, I don't know anything about developing UIs. Like that is just a different part of the brain. My wife's a graphic designer. She gets more into that sort of stuff. I don't get it. It makes things pretty. UI is user interface. Good question. Next acronym, API, is sort of the opposite of that. It's the application programmer interface. So that's developing programs that allow programs to talk to other programs. It can get really meta really quickly, but it's sort of just like a web URL that you go to and then you get a response back. So you sort of throw something over the wall and then you get something back. So it's only as complicated as you want it to be, but it can be very complicated. I keep hitting the wrong button. I probably should have looked at my slides. So yeah, so these are the normal, as I mentioned, the normal applications. And then we have the UI stuff. UI is, again, making things pretty, making things interactable. And then, as I mentioned, the API stuff. So if you ever hear the term microservices, that's sort of this realm of programming. A lot of industry today is like overly focused, I'll say, on microservices. So everything's cloud-based, everything's its own neat little package, and then you sort of wrap that together, and then you wrap that with other stuff, and then you wrap that with other stuff. So you'll have like 5 or 6 of these API gateways with hundreds or thousands of microservices, and it gets really, really messy. There's a couple tools that we need to go through. The first one is an IDE, or an integrated development environment. That is essentially your, y'all are going to hate me for this, but it is your Microsoft Word for code. It is how you type the letters out. It is how you run the code. It shows you errors, shows you bugs, stuff like that. That is your main, what was that? It does give you help, hopefully. If you understand the help. Sometimes the help can be cryptic. Like if you go to some of the old C programs, some of the messages aren't as nice, we'll say, as like Rust error messages. So it sort of depends on the language, the tools installed in the IDE. Most IDEs have a plugin system, so they're very modular. VS Code sort of helped establish that. And VS Code's great. I don't have anything against VS Code, even if it is Microsoft. When we get to the live demo part, we'll be using Vim, which is in the terminal. Figure that's more hardcore and Linux audience, but it doesn't have to be in the terminal. The terminal, as we know, is great and awesome for developers. But if you're a Linux newbie and you're still sort of scared of the terminal, you don't have to use it. You can use the IDE, and they have a little mini terminal built in where you need to do your 1 to 2 things that you have to do in the terminal. So don't be scared of it, but you absolutely don't have to use it. The next one, it will be compiler. Do I have this? We'll get in there in a second. So the compiler is what takes your written code that's technically human readable. Maybe not if you're not a programmer, but it uses keywords like if, while, else, stuff like that. And it translates it into machine code. So that's the actual binary, the ones and zeros. That is what your computer actually runs. And it's called compiling. There's actually a couple different steps. You compile, and then you link, and then you assemble, and it's a lot of steps. That sort of just all gets wrapped up into compiling. There's also interpreting, which we'll get to in a second, which is similar to compiling. It's a way to run your program, just like compiling does, but it doesn't do it all at once. It sort of runs it as it goes. And we'll take a look at that in a little bit, like I mentioned. The last one will be Git. Is anybody familiar with Git? I feel like most people are familiar with Git. Okay. Is anybody not familiar with Git? It's okay to admit it. Okay, cool. Yeah, that's fine. So Git is a source control repository. It's basically how you check in your code. So if we work on distributed teams, like half of my team's in the Czech Republic, I'm not going to go hand them pieces of paper of code. That's just not efficient. So we have a Git lab, which is an instance of Git. That's a website. And I check in my code to Git lab. It goes up to the server, and then they pull it down on their machines. And they make little changes and pull it back up, and then I pull it down. So it's a way to sort of facilitate sharing code between people. And there's also really nice features like you can review code in there, you can link to different Jira issues, or you can manage your Kanban boards and stuff. But at its core, GitHub, GitLab, and these other services are focused around sharing code efficiently. So one of the things I was kind of touching on was the different types of languages. There's a lot of different ways you can slice up programming languages. One of the most fundamental is compiled languages and interpreted languages, but that's not even really technically correct. you can have things like Python has the PyJIT, where you can do just-in-time compiling, so it feels interpreted, but it's compiled. You don't need to worry about that. If you keep it at its surface, some languages that you have to build ahead of time and deploy, and then there's some languages you can sort of run as you go. Another way of, okay, yeah, so this was at an anime convention, so there you go, there's your anime. Also, fun fact, this is from an anime called New Game, which is about these cutesy little anime girls. They're like, I want to be a video game developer. And like, cool, you need to learn C++. And they have null pointer dereferences, and they cry, and it's awful, and it's awesome. So go watch the New Game. Yeah, so the compiled languages, those are the more traditional languages, like I was mentioning, you build ahead of time. C, C++, those are the old languages. They're great. They're a little rough around the edges, but there's a lot of modern features that don't really get talked about. Like if you look up documentation for C and C++, you'll get stuff from like the 80s, 90s, early 2000s, and it's like, well, I don't know if that's necessarily in date or out of date. C++ especially has a lot of modern features that just don't get talked about. Rust and Golang are some of the new languages. They very much take the ideas of C and kind of go different ways with it. Rust really forces you to get everything right ahead of time. So when you write a Rust program, you compile it and it runs, you know there's certain class of bugs you just can't have. There's certain errors you just can't expect with Rust. And that's great. But that means you have to be perfect ahead of time. You have to sit there. A lot of times it feels like writing the compiler. You write code and it says, oh, you can't do that. Okay, well, I'll try this. And it's like, well, you can't do that either. So there's a lot of iterations even to get like a proof of concept. And sometimes that can be challenging, especially if you think of like new tech startups and that sort of thing where they want to do rapid iteration. That can be a little harder with Rust. Golang is sort of the opposite. It's designed to be a simple language. It is designed to be a very lightweight in the terms of like not a lot of keywords, not a lot of fancy syntactic sugar. So we're going to use Golang today. If you've never programmed before, Golang is a great language to start. I'm just a big Golang fan. The other ones are great. You can use them on your own time. As I mentioned, the other languages are the interpreted languages. These are really good at rapid iteration because you sort of run them as you go. A lot of times they have what's called a REPL, or a read, execute, print loop, where you can sort of just, you don't even write it in a file, you just write the code as you go. It's almost like a shell for Python or a shell for JavaScript. Bash is a language. Fun fact, you can write bash scripts and it is interpreted. I've been told several times if you are doing complicated stuff like arrays in bash, you're doing something wrong. So if you ever feel like you need to do an array in bash, learn Python. That's my advice. I just hate the syntax. I love bash, I just don't understand the array syntax. Okay, so now we're going to get into the actual code, the actual code. So I'm going to just get rid of this, and bada bing, bada boom. Sweet, y'all can still see that. And because I am using Tmux, I can see that as well. Sweet, okay. So, one of the first things we're going to do, the first thing any programmer does, we can still see this, perfect. Can everybody read this? Is this font? I know it's kind of a weird font. It's actually called Daddy Time Mono. I picked it because it's a weird name. So yeah, but I can make it bigger if we want, but that's fine. Yes? By the way, I know what it is, but you might want to explain to people what Tmux is. That's a good point. So Tmux is a terminal multiplexer. So by default, the terminal emulator that I'm using, which is called Alacrity, it doesn't have tabs. So if I wanted to do multiple things in this one terminal, I'd actually have to open multiple terminals to do that. So one of the fundamental features is it opens tabs. So I can have multiple tabs. You can see at the bottom, well, maybe you can't because the font's messy. On my screen, I can see at the bottom that there's different tabs for each window that I have open, and it allows you to easily hop between different files and things like that. There's also plugins, so I can see my battery percentage, I can see the weather in the terminal. You really can do everything in the terminal, and I basically live there. So one of the first things we do like I said, we're in this directory, and we have a bunch of Go files. You know they're Go files because they end in .go. Go loves Go. Everything about Go says Go. If you want to use the Go tools to build something, you say Go build. And then it produces a binary, which are, again, the ones and zeros, based on the name of the file you give it. So in this example, 00 hello world is green because it's executable, because it's a binary. It's not necessarily always true, but in this case it's true. So I can run it like I would run any other program, and it prints hello world. Go is, it's so fast and so simple. It tries to be an interpreted language, and you can do wacky stuff like go run hello. Oh, if I can learn to type. So that just compiles and runs in the same step, and it's like, ooh, it's interpreted. It's not. Don't be confused. But yeah, so you have some source code. You can compile it, and then you can run it. So once it's compiled, it's like any other program. We're actually going to remove that really fast. And then, yeah. And we even saw in a quick example here, you see on the right side where it says untracked main, and then down below it just says main. In my bash prompt, I have the get status, so you can sort of just see at a glance, oh, did something change? Is there a new file? Is there something like that? So if I create a file here and then do a get status, we can see this new file that I just created is not in the Git server. So it is local to my laptop. Nobody else can see it. So then you would either add it and commit it and push it to the server so everybody can see it, or you'd be like, oh, I actually don't need that, so I'm just going to delete the file. So, but this is not a Git tutorial. We would be here forever if it was a Git tutorial. So we are going to hop right in. We're going to use, it's actually NeoVim, but I aliased Vim to NVim to save a single character because I use Vim. So, yeah, at the very beginning, we have hello world. If you've never programmed before, the first program you will write is hello world. It's written down somewhere. I don't know where, but somewhere, I'm sure. And as you can see, we're going to skip the first 2 bits. We'll come back to them in a minute. But starting at line 7, we see func, which is how Golang defines a function. And then it is called main. The first function is always, the first function you execute is always called main in Golang and in most languages. So this is the main entry point to the program. We don't necessarily have to know what functions are yet, but just know that everything starts in main. So inside of main, first thing we do is use the format. I'm not going to try and pronounce it as it's written. It is the format package, which defines a function called println. So what packages do is as you define functions, you can export them and let other people use them. These are typically called libraries or however you want to talk about them, but it's a way to write little snippets of code that can be used elsewhere. They're not necessarily whole programs, but they're used to build other programs. So for instance, this function that's defined elsewhere allows us to print to the terminal. And we're just going to print hello world because it is the standard thing that we do. And then as you can see here, we are defining our own package called main. We're importing a package called format. That's where the println function comes from. But then inside of our program, you always have to start with main. So that was a very basic example. We're going to move on here to the math to do a little something more interesting. So before we just wrote the string, which we'll talk about strings in a minute, and we just printed it to the terminal, but we didn't necessarily store it anywhere, and we didn't necessarily know what type we were using. So one of the most fundamental things you can do is define a place to store information and then also tell what type of information that is. We do this with variables. They're called variables because they can change. There's also consts, which is kind of fun to say into a microphone. So I could say like const, if I can type, foo, so that it's the same idea where you're storing information and you're storing a type, but const, they're called const variables, which is also weird. Const variables are not allowed to change, but variable variables are allowed to change. So here we are defining three types of information, three pieces of information, called x, called y, and called sum. And all three of them have the type of integer. So that is a whole number that doesn't have any decimal places, keeping it simple. But we don't necessarily know what information is. We've defined a place for that information to go, but we haven't assigned a value to that information. That comes in lines 12 and 13. So the equal sign, a single equal sign, is not like the mathematical equal sign. This is called the assignment operator. It means take whatever value is on the right and assign it to the left. So we are taking the value of 2,000, storing it on the variable on the left. And we know x is an integer because it's right here on that we declared earlier. And this is also one of the nice things about an IDE, an integrated development environment. Let's say this is like 1,000 lines long, and I don't remember what type x is. Because I have plugins with NeoVim and it's super cool and fancy, I can just hit Shift-K to show the documentation for that variable, and I can see it in place what type it is. So I don't necessarily have to remember all these crazy different things. It's right here. Just go to it, hit Shift-K, boom, documentation. You can also hit GD to go to definition, so it'll literally take your cursor to where it's defined. And there's a lot of little tools like that. You would spend your whole life learning Vim commands, and you would still not learn them all. But anyway, back to programming. I'm getting sidetracked a lot. So we are defining, or we are assigning the information on the right to go on the left. So now the value of x is 2,000. The value of y is 23. And the value of sum is the value of this operation. So it is still math. We do still have order of operations. We do the addition first, and then we assign all of that to sum. So as we can probably guess, this will say hello to 2023. So again, very basic, but I just want to get some of the syntax out of the way. One piece of syntax here that is going to be used a little bit, sometimes this can be a little tedious to write every single time, where you declare all the variables first and then you assign to them later. So there is a shorthand. So let's say I want to delete these. I can say x colon equals 2,000. And in Go parlance, that means you figure out what it is. It is determining the type of the variable based on the value of the variable. You don't necessarily have to know what all that means, because we're in an IDE, we can hit Shift-K. It shows it is still a variable called integer. Does that make sense? Cool. So I'm going to undo. And that was actually just the next file here. So again, very basic. So the next cool thing we can do, we've sort of mentioned how we can have places to store that information, but what if we want to group the information together? The way we do this in programming is with a data structure. There you can take a lot of classes on data structure and algorithms, and you can go to very complex data structures. But at its core, a data structure is just something that co-locates pieces of information. So in this example, we are defining a type called rectangle that is a struct. And we are defining the struct that has a length, has a width, has a name, because I made the rectangle. I can make it have whatever I want. I could say this rectangle has a circumference or has a radius or whatever. It wouldn't make sense, but the program would work because that sort of logic isn't baked in. It's, I am in complete control of this program. I can make it do what I want. Which is actually how I got into programming. I'm a little bit of a control freak, but that's a separate discussion. So we define this rectangle struct, and we are saying everywhere the rectangle goes, it is going to bring a length with it, it is going to bring a width with it, and it's going to bring a name with it. But that doesn't necessarily, again, say what those values are. So we, in our main program, in our main function, we are defining a spot to hold a rectangle, and then we are assigning the value of r to be length of 5, width of 10, name of test rectangle. Geez. And then at the bottom, we're printing it out, and this is how you access the variables of them. They're called the fields of the struct. R.name will be test rectangle because it is the name defined on the rectangle that we instantiated on part 16. The more you think about it, the more confusing it can get, but it really is just as simple as thing.field. So r.name, r.length, r.width. And you can nest these. So let's say you had a car object that has a wheel object that has a number of lug nuts that has whatever else. And in that scenario, you would just do like car.wheel.lug nut, and you just make this whole chain of things. We're not going to do that today because it's a little tedious, and I didn't feel like it, to be perfectly honest. But as you can see here, we are accessing the fields. You can perform operations on the field because it is still just data like anything else. And as we can probably guess, when we run this, it will just say the test rectangle has an area of 50 because it is basic math. Cool. I haven't lost anybody yet, have I? We're following along. Cool. Haven't done anything too crazy. So, defining our own functions. This is where programming gets more interesting, honestly. There's actually a whole section of programming called functional programming, and it deals with like passing functions into functions and all this other crazy stuff. I don't deal with functional programming. It's too mathematical for me. But it's good to know that you can go very far one way in programming, or you could just avoid it completely, and it's totally fine. We're going to avoid it completely today because we're going to keep it simple. So in this program, we have the same structure as before, the same rectangle. It has the same fields. It holds the same information. But now we want to define a standard set of operations. So this is sort of getting into that recipe idea. Like we want to say, step 1, you mix your dry ingredients. Step 2, you mix your wet ingredients. And this function only has one step, but I don't want to have to constantly remember, oh, should I multiply length times width, divide, or whatever. In this example, that's obviously easy to remember, but you can think of a complicated function that has 100 different lines, and you can code them once and just call them multiple times, and you know it's going to process in the same way. So, in the Go language, we are defining a func, which again is a function. The function is called area, and then everything inside the parentheses is input. Everything outside the parentheses is output. So it takes in a rectangle, and it spits out an integer. And because we are going to use the rectangle inside the function, we give it a name, call it rect. And again, it's the same math we've been doing. It is rect.length times rect.width. And that return means spit it out the function. We are leaving the function and take whatever value on the right, and that is what the output of the function is going to be. So, in main, which again is its own function, but it's a special function, we are defining a rectangle using the special colon equals syntax. It's the same rectangle as before, but now when we're trying to get the area, we don't have to remember the formula for area. We just say area r. We just say call this function, put the rectangle in it, you figure out the math, which is great for me because I don't like doing math. But it's important to know it gives us the same output. It is just a different way of doing the same thing. When you're the programmer, you get to decide how you want to do things. You might say, I like doing math. I like typing the same thing hundreds of thousands of times. Go do it. I'm not. That's what functions are for, to reuse operations. And in the same sense, we were talking about how to collect fields of information, and we group them into a data structure. What if we want to collect multiple data structures? What if who here likes video games? Okay, a lot of people. Basically, all video game graphics are is a collection of triangles. You will make a triangle, spit it out on the screen, and add it to a list of like a bajillion other triangles, and they all relate to each other. But they have to be maintained together because these group of triangles represent Tomb Raider. These groups of triangle represent the wall you're trying to climb on or whatever, and they have to have different responses to different inputs. So in this example, we have the same rectangle as before. We have the same area function as before. And in our main function, what we're actually going to do is create an array of rectangles. Now, this is actually kind of a lie. In Golang, this is actually a slice. You don't have to know about all the semantics of a slice, but when you have these brackets here, you can put a collection of rectangles together. They all have to be the same type, so you actually have to define the type up here. It is a collection of rectangles. And as you can see, my ID is actually telling me this is redundant. Because we know it is a collection of rectangles, we know everything inside is a rectangle. So writing rectangle twice is redundant. So we can delete in Word here, and then it's a bunch of curly braces and numbers. And maybe you like the syntax, maybe you don't. That's completely up to you. For the purposes of the demo, we're just going to leave it like this. But then we have this R, which is a collection of rectangles. Well, what do we do with it? One of the first things we can do is just print the stuff out like before. So we can index the slice, index the array. All arrays start at 0. That has something to do with C and memory and tradition and honor. I don't know. It's everything starts at 0, and if you bring it up, people get mad at you. So R is the first rectangle. It is the first element in the R array. And we're going to access the field. So we're sort of already nesting things here. We're getting the field of the element of the array. But again, we can just pass that into area, the function, because R0 is a rectangle. So we know the type, so we don't necessarily have to think about whether it came from a collection or not. Where it is now is an array, or is a rectangle, excuse me. And we could access the second member of the array, just do an R1. But maybe if you let's say you have a collection of 1,000 rectangles, you don't want to necessarily type out each one multiple times. And even still, I could have done this, and this would be an error. Where am I on the screen? Yeah. So this would be an error because I did R0 first, R0, that's good. Then I did R1.name and R0 area. That'd be wrong. And there's nothing stopping it because the values are correct. So how do we make sure we do a simple set of tasks for everything in the collection and make sure we're only operating on one element of the collection at a time? That's where loops come in. Golang has a interesting way of doing loops, I'll say. You use this operator called range, which range returns an element of the collection, and it actually has the index and the element. So in here we have the variable called I, the variable called rect are defined from the range of R. So that returns 0 and then the first rectangle. And because we're doing this in a for loop, that means it's going to be constantly running until we're out of elements. So there's lots of different ways to do for loops. That's absolutely something you can and should go look up on your own. There's the traditional way where you do like for integer I equals 0 up to some number. With Golang, you see this variant a lot because it's saying whatever the size of the collection is, just go run everything and we'll figure it out. So in here, I'm calling the familiar print line. We're spitting out the index so we know what slot it's in. But then it's the rectangle name and the area rectangle. And we're actually not supposed to see this. Don't worry about that. So if I run this, we see the test ranked rectangle has an area of 50. That's from the first. Are you seeing this? You are not. Okay. So we are in array. So I can do this. No. Now can you see that? Cool. Okay, so I just ran it manually because the resolution's being funky. But you can see the first line where it says test rectangle has an area of 50. That's just the manual way we did it, where we said R0, blah, blah, blah. The second way, it runs once for each iteration of the collection. And they're formatted identically. The math is going to be the same. It's going to be very rigorous compared to the other way, which is a little more loosey-goosey, we'll say. So, this section probably isn't going to make a lot of sense until we move on to the later sections. So just bear with me through methods. One of the things that's a little confusing about the way we defined area to begin with, Well, you can have multiple parameters. Like I can have multiple things in this input. So I could say like, I don't know, taking an integer here and times I, whatever. But then when we define fields on a data structure, the primary purpose was to say, take this group of information with you everywhere you go. So wherever there's a rectangle, there's a length. Wherever there's a rectangle, there's a width. But we haven't necessarily done that with the collection of operations. So wherever a rectangle goes, maybe we can call its area, maybe we can't. It's sort of disjoint. So we can attach the methodology to the data structure itself. And again, this is where Go gets a little weird compared to other programming languages. But you have a separate set of parentheses called a receiver. So what data structure is going to receive these operations? In this case, it's going to be the same rectangle as before, length with name. You give it a variable name, and then you just say r.length times r.width. Notice there's no input now because we already have the rectangle from the receiver. We know this is only going to be called on the receiver. So it's fine. It changes the way you write things. Maybe you don't necessarily need this. I can do this, and that works. And again, this is just showing you the different ways to call these. So we have the loop as before. We call index rectangle name, and we can say area rectangle or rectangle.area. In this example, it doesn't make sense why you do one versus the other. And in some languages, you can only really do one. In C, I believe, you basically only ever see this syntax. So why would we do it this way? Well, that comes to play when we start talking about interfaces. So let's say it's going to be here. Okay. Nope. There we go. My Vim foo is a little off today. So let's say I have in here individual loop, and I am defining an array of rectangles that has 2 rectangles in it. Man, that is really bouncing all over the place, isn't it? Anyway, we have a collection of circles. I'm sorry, guys. I tested this on an external display, but it was a 4K TV, not a 720p projector, which is fine. It's fine. Anyway, we have a collection of rectangles that has 2 rectangles in it, and we have a collection of circles that has 1 circle in it. Collections can have 1, they can have 0, they can have a bajillion. There's really no limit on what you can have other than physical memory of your system. And it doesn't even necessarily matter what the circle is. So I'm not necessarily going to go to the circle definition, but it is what you would expect for our circle. And then let's say we have these 2 collections of information, and we want to perform similar operations on them. If you haven't been paying attention before, please focus in. This is the really the only important takeaway. If you're programming, one of the best skills you can have is pattern recognition. If you can notice patterns and extend them to other patterns or take multiple redundant code and merge them into one, you're going to be an excellent developer. So a lot of red flags should be going off here specifically. We see a collection of something, and then immediately another collection of something. And then we have some operation, and then immediately what looks like exactly the same operation, because we have circle name and circle area. They even have the same function call and the same signature is what I was trying to say. So there has to be some way to combine these, right? Well, let's say, what if we just want to throw a circle in here and say circle, boom, radius 10. Let's see if we want to do this, right? It's going to say, well, it's going to say I don't know how to type still. Then it's going to say, man, I really don't know how to type. There, and then it's going to say, at the very bottom here, it's a little cut off. It's saying you can't use a circle in a collection of rectangles because a circle is not a rectangle. Duh. So what we need to do to get around this is we basically need to sit back and say, well, I don't actually care if it's a circle or a rectangle. I don't actually care what the data structure is in this instance, I only care about the methodology that's attached to that data structure. In this instance, all I care about is the name and the area. So one thing we can do, if I just close this up here, bada bing, bada boom, we can define an interface. So much like a data structure is a collection of fields, an interface is a collection of methods. Golang, again, is weird because it's Go. Everything is implicit. So what that means is you don't necessarily say this structure is this interface or it implements this interface. It just sort of figures it out. If you define these two functions exactly how they are on your data structure, you can use it to replace the interface. So how that looks, if we go back to the main function here, we have the single loop. So we have this interface called shapes, and we can define a collection of shapes. We can say, give me a collection of shapes, and where the first one is a rectangle, second one is a circle, and then the third one is a rectangle. And they don't have to be grouped in any sort of way. You can sort of put them however you want. But now we only have one loop, because we know the shape has a name function, or a get name in this case. We know the shape has an area. We don't care that they're different implementations. We just care about the signature and say, hey, can I call them? So again, you're sort of layering this code up. So you call the interface, and it figures out what data structure it is, and then that function, which calls on these field methods, and it's sort of this nested web, but you only have to care about the very top level. So there's going to be a lot of layers of abstraction in programming, but you only really have to focus on one layer at a time. And we can run this. So if I hop out of here, no. Go run, is this 08? Nope. So if we run this, we can see the first loop, which is, this is going to be the first way of doing things. We're iterating through a rectangle and then a square and then a circle. And the indexes are off because they're different collections, so it's not going to keep the same numbering of indices. But then in the second one, it is going to keep the same collection, or the same numbering. It's 0, 1, and 2. And we see the rectangle, then the circle, and then a rectangle again, or an actual square, really. But it sort of figures it out for us. We can sort of group it however we want because we've stopped caring about the fields and only cared about the methodology. Now, that's all I'm going to talk about today. Those are the absolute basic building blocks. There is a ton more to get into. But if this is something that sort of gets you going, it excites you, there are some things we can look at here. So there are some extra resources to get started programming, start off easy bite-sized chunks, and build your way up. The one I recommend the most is Advent of Code. Who here has heard of Advent of Code? Who here has completed all 25 days in a year? Okay, I haven't either. I've gotten to like day 7. But what it is it's basically, it starts in December of every year, and for each day of the Advent calendar, you get a coding problem. And it's super cutesy. It's like, oh, the elves got separated from Santa. You have to help them by writing code to like program their reindeer or something. It's really off the wall, but it's fun. And it starts off very simple. Like day 1 is bog standard, easy programming. And it's great to make sure your environment is set up, make sure you actually know what you're doing. And then there's a couple more easy ones, and then there's an inflection point where it's like, oh, this is hard. So I don't recommend forcing yourself to do like, oh, if I don't finish this one today, then I can't start the next one or whatever. If you need to bounce around, you can look at the previous years. But they're a great set of problems to look at and sort of get your feet wet, see if this is what you want to do. The next two, they're pretty similar. There's Leet Code and Code Wars. Who here knows what Leet Speak is? Okay, that's mostly everybody. Good. I don't think this has anything to do with Leet Speak. They just wanted to sound cool and edgy and with the kids. So Leet Code and Code Wars are great because, again, they're a set of problems, and you sort of get one at a time. And they're grouped by like easy, medium, hard. I'm not as familiar with Code Wars. They might have a different grouping, but there's some difficulty rank. So you know oh, this is a hard problem, or this is one I should understand and figure out. So they're really great there. But what they also do is they allow you to say, okay, I solved the problem, but how does my code compare to everybody else? You see, my code executes, it solves the problem, but maybe it uses twice as much memory as somebody, or maybe it's twice as slow as everybody else. So it gives you that extra step of, okay, let me go review my code, see if there's any optimizations I can make, or just remove code, stuff like that. So I'd say that's a great second step. There's also a really high ceiling with Leak Code and Code Wars. A lot of people use these before technical interviews to sort of brush up on their skills, make sure they understand things like that. Yeah, those are my top 3 resources. And really, there's a lot of stuff on YouTube, Twitch. There's a whole bunch of people. I think now really is the best time to get into programming in terms of availability. Like, there are resources everywhere. There's still college. You can still go to college if you want to. I went to college and it was great. There's boot camps. I know people who go to boot camps and get great jobs and they love it. You can also be self-taught. I know our senior engineer or senior architect, she's self-taught and she's been doing it for like 15 years. So that is absolutely an avenue you can go. But you really have your pick. Yeah, and I really don't know. I don't think there's any reason not to start programming. It's never too late. Especially some people think programming's like, oh, that's just for the young whippersnappers or whatever. But I mean, there's people who have been programming for feels like 75 years. That's not true, but feels like they've been programming forever. There's also other people who started late and are phenomenal at coding. I think a lot of this has to do with how your brain is set up. It is a skill you can learn. I feel like everybody can program, but there is a sort of aspect of, are you a math-minded person? Are you a creative person? Stuff like that. So finding your niche in the programming world may be a little difficult, but you should absolutely get started. The hardest step is actually trying it out, getting the stuff installed on some random laptop you have in the closet or whatever, and just getting your feet wet. And if you try it and you suck at it, or you don't want to do it, or you hate it or whatever, cool. You don't have to do it, but it's free. All of these links are free. A lot of these programming languages and tools and whatever, they're free. And everybody should be running Linux here today. I shouldn't say should, but if you are running Linux, a lot of the stuff is sort of out of the box. It's sort of think about programmers first. Yeah, I'm going to end that rant there. That's all I have for my my demonstration, my talk. I did want to leave some time for questions. I think we have 15 minutes. Yeah, so are there any questions from the audience? Yes, so on talks.reaves.dev, which I got really ambitious. Let me do Modchif 2. Nope. That's not what I want to do. Yes, it is available, and I can't figure out how to work this. Modchif 2. There it is. Okay. Okay. And then we bada bing, bada boom. Okay. Boom. That's it. Yes, so there is a QR code with the URL to that same website, which currently has a single talk on it. I'm sort of new to this giving talks, and I'm actually rewriting how this website's going to be. But that URL will still be valid, so that QR code will still be valid. Yes, to answer your question. And then I think you had a question as well? Yes. Yeah, the business column said they don't like naming every one of their rectangles. What do you do with that? I mean, you can change it. Yeah, so like we could go in for the field names or change it. Again, that goes to the code. You could also touch on interacting with databases, which is a little different. But a lot of times the information isn't necessarily stored in the code itself. It's stored somewhere external. And you have to pull in the information and then operate on it. So I what's called hard-coded everything. I just like baked all the information directly in the code. Most of the time you don't want to do that. Because if we had to change this, I'd have to change my whole application, redeploy everything, talk to the infrastructure team, get stuff up and running. Whereas if it's in the database, you can just change it. So it's a good question. I don't know if that's where you wanted to go with it, but yeah. Yes?
Go is one of those languages that can be learned for quite a while. But there were some surprising things in the syntax.
Mm-hmm.
Those area functions, those two you defined in the last example, are those called methods in Go, or are they just
Yeah, they're called methods. So a function does not have a receiver. A method does have a receiver. Um, yeah, it's somewhat arbitrary. I think the term is because when you talk about functions, you really want to get into pure functions that don't have any side effects. That's a whole other rabbit trail we can go down to. But yes, they are called methods. Yep. And there's actually, if you want to learn Go specifically, there is a website. I think it's called the Go Playground or Tour of Go or something like that. It's made by the Go developers, and it walks you through all the features of Go. Some of the stuff, it sort of expects you to be a programmer to understand it, but that doesn't mean you can't wrestle with the particular problem for a couple days or whatever, figure it out. It goes into concurrency and recursion and stuff like that, so it gets pretty gnarly pretty quick. But that's sort of the main features of Go, is you can run it on the cloud, and it runs thousands of instances easily. So, yep. Any other questions? Yes. Okay.
Thank you for that program that you had, this rectangle, the circle, and the square. I am a high school geometry math teacher, and now I have a reason for explaining why every square is a rectangle, not every rectangle is a
Yes.
square, and if you don't believe that, here it is in a computer program.
Exactly. And computers don't lie. Yes. That's great. That's awesome. Okay. Yes, one in the back.
Yeah, I'd also just point out that you kind of touched on this in the beginning, but there are many different areas of programming you can get into, and they require different sets of skills.
That is true.
Try something, and you're like, this is not for me. You may want to look at other areas. I took in 100 days of code, and I think
Okay.
web development, and I went to 80 development.
Yeah.
You go many different directions with this and be as abstract or as opaque if you want to make it.
Yeah, absolutely. Game development is completely different set of skills. I mean, it's still programming, and you a lot of times still use a code editor, but you have to think about problems in different ways because your code runs every frame. Whereas I do API development, it runs every network call. So there's different overheads, different things to consider. Yeah, and there's also different styles. Like there is a predominant style in web development. That doesn't necessarily mean that's going to work in game development. So that's a very good point. Try different fields within programming. Anything else? Cool. Well, thank you guys for coming. We got a little bit of time left if you want to hang out, talk, or go get some lunch. I know it's almost lunchtime. Thank you guys for coming.
Thank you.
Yep.